All right, page 201 in your textbook. Yesterday, we looked at reviewing these step by step. So if you need some additional help, be sure to watch that video. Go back in your book to look at notes. So page 201. When it's already as a decimal, I would suggest just putting it into your calculator. Right? So don't forget, if you're doing this by hand, to keep, switch, switch. So in other words, our signs are different, which means we're finding the difference and we have to subtract. So we would say big minus little. 90 hundredths minus 45 hundredths is 45 hundredths, but I will borrow and show you that. So 10 minus 5 is 5, 8 minus 4 is 4, bring down your decimal, 3 minus 2 is indeed 1. Okay, so that's what your calculator should have come out with. 2 should have been positive because our bigger absolute value number was positive. All right, so here too, keep, switch, switch. Our signs are now different. I'm gonna let you figure out these other in that row. I'm just gonna kind of keep going down this left column here. Although it looks like I'm gonna jump across and do numbers. Well, I'll do number 6 with you because it looks like you'll get something similar with number 9. So let's do this column and also number 6. So I'm going to do 4 more with you, and then you're going to have some things to practice, okay? So of course, you could just put this into your calculator. You should also know that this is the same as negative 6.2 plus a negative 3.7. Or negative 6 2/10 plus a negative 3 79/100, right? It's good for you to practice saying these. Ethan, enough. I don't care who's talking first. If you're talking, you're in trouble. Can you let Kelsey in, please? All right, now our signs are the same or different. They're the same. So we're actually finding the sum. 6 2/10 plus 3 79/100. So there's only 9 hundredths, there's 9 tenths now, and there are 9 ones. 9 and 9. However, is this positive or negative? Negative, because our greater absolute value number wasn't it? Excuse me, negative. Exactly, both of them are negative. So it's only can get more negative.
That's what I did. This word
all right. These, you're going to probably have to keep, switch, switch. Can you change these into decimals? Probably quite easily, frankly. 5 9/10 would be 5.9. 8 2/5 is the same as 8 4/10. So that would be plus 8 4/10. So I probably would put those into a calculator, or let's go through the process of doing them as fractions. So 5 times 10 is 50, plus 9 makes 59. We keep our denominator the same, plus 8 times 5 is 40, plus 2 is 42/5. What do I need in order to add fractions? My denominators have to be the same. What's a common multiple between 10 and 5? Will they both go into 10?
Yeah.
Yes, so I can keep my first the same and add, good. So in order to change this to 10, I would have to multiply it by 2. So that's what I have to do to the top. So I have 84 tenths and 59 tenths. So of course, this is a little bit complicated. 9 and 4 is 13. 9 and 5 is 14. When I divide this by 10, I can move my decimal over 1, or I could take out 14 and 3/10. And that's as simplified as that fraction gets. So if you put this into a calculator, 9/10 and 4/10 is 13/10, carry the 1, 9 plus 5 is 14, and 3/10. So either way, you should get one of those two answers, okay? Questions, concerns? You can definitely turn those because they are terminating decimals into decimals. With number 7, can I use decimals? No. You would quickly find out that 1 divided by 6 is a repeating decimal, so I cannot use decimals. I have to keep these as fractions. So I'm thinking, what is a common multiple of 8 and 6?
Um,
8, 16, 24. Does 6 go into 24? Yes. So 8 times what is 24? 3, right? So 7 times 3 is 21. I haven't changed these into improper fractions yet, but we can if you want to. We'll keep this as a mixed number for now. 6 times what is 24? 6 times 4 is 24. Guys, if you don't know these right off the top of your head, be sure that you're practicing your multiplication problems. So whatever I do to the bottom, I have to do to the top. 1 times 4 is 4. Now, are my signs the same or different? They're both negative, so we're really finding the sum. What's 21/4 and 4? I'm sorry, what's 21 24 and 4 24 combined? What's 21 plus 4? 25. Excellent. So 25 24ths, but I can't forget that I also have a 2. And this is more negative. Now this is an improper fraction. So if I take, how many 24 pieces can I take out of 25? Can I take out all 24? So that would be a whole. So I have one more whole. And what's 25 minus 24? Just 1 remaining out of the 24. You can also change these to improper. So you have negative 21 24 plus a negative 2 times 24 is 48. 48 plus 4 is 52. So 52 and 21 would make 73. 73 divided by 24 would be 3. 3 times 24 is 72. So 73 minus that 72 would leave us with one of those 24. So either way you do it, you should end up with -3 and 1/24. Can you get this in a decimal answer? No, you cannot. You need to do this as fractions. Same with number 10. You have to use fractions. So keep, switch, switch, and then you're finding common denominators. I'm going to leave it like this. I'm going to let you do this one. This one's pretty simple. What common multiple do these two have? And then what do I do to the 6 to get that? That's what I have to do to the 5 to get my equivalent fraction. What do I do to the 4 to get that equivalent denominator? Whatever I multiplied the 4 by, that's what I have to multiply the 3 by to get my new fraction. Then I'm adding across. You may not. Nope. I'm sorry, grab some Kleenex. Can use some hand sanitizer. All right. So we're completing the practice today, 201, 202. Remember, when we're evaluating, we're simply putting these into the equation. Remember to include parentheses. Put your x value in here. Put your y value in here. Same thing for 15. Try 14. On page 202, you then have some word problems, right? All right, so try those practice on 201 and 202 today.